Imagine the universe as an endless cycle, a universe that, far from being a one-time event, continuously reinvents itself in a cycle of birth, evolution, and rebirth. This idea might sound like science fiction, but it's a serious theory called Conformal Cyclic Cosmology, or CCC. Today, we're going to explore what CCC is, how it works, and what it suggests about the ultimate fate of the universe. Conformal cyclic cosmology is a bold and revolutionary cosmological model proposed by British physicist Roger Penrose in 2002. It challenges the conventional understanding of the universe's origin and ultimate fate. According to the standard model, the universe began with the Big Bang and will either continue expanding forever or eventually collapse in a big crunch. However, CCC proposes that the universe goes through an infinite series of cycles, or eons, with each one emerging from the previous one. This idea stretches our perception of time, suggesting that the universe has no beginning or end, only an eternal, ongoing sequence of cosmic eras. Let's break down the core components of CCC. To understand how these cycles work, we need to look at two major concepts: conformal symmetry and the nature of infinity. First, conformal symmetry refers to the idea that the universe's geometry can be preserved under certain transformations, like stretching or compressing. In CC, Penrose argues that the end of one universe, during a period when the universe is completely expanded, can smoothly transition into the beginning of a new universe, just as the shapes of objects can be preserved under stretching or squishing. The key insight here is that at the farthest reaches of an old universe, where space has expanded so much that all particles are nearly motionless and distant from each other, the universe approaches a state where space-time becomes conformally invariant. This means that the old universe can smoothly transform into a new one without a violent Big Bang. Instead, the transition happens more gently, like a seamless handoff between cycles. Now, let's talk about the role of black holes in this theory, as they play a central part in the evolution of the universe according to CCC. Throughout the life of a universe, black holes form, grow, and eventually merge. According to Penrose, when these black holes evaporate via Hawking radiation, a theoretical process where black holes slowly lose mass over time, they leave behind only the energy and information encoded in the radiation. This process, known as entropy reduction, ensures that the future universe will be free of the high entropy left by the previous one. The incredible thing about CCC is that Penrose believes this entropy reduction is critical. At the end of one eon, the universe's entropy is essentially reset, creating a fresh start for the next eon. This process allows for the universe to continue cycling indefinitely, with each new cycle having no memory of the previous one, despite being connected through this transformation. So how does this work on a cosmic scale? In CC, Penrose imagines the entire universe as a conformal manifold, a kind of mathematical structure that allows for the transformation of one eon into the next. He envisions that the end of one universe, filled with empty, cold space and black holes, is matched with the beginning of the next universe, in a way that preserves the overall structure of space-time. In other words, at the end of one universe, we reach a state where all matter has been transformed into radiation, and the universe is completely homogeneous and isotropic, meaning it looks the same everywhere. This state, known as the cosmic horizon, is the perfect starting point for a new cycle. So, if conformal cyclic cosmology is true, what evidence could we look for? Surprisingly, Penrose suggests that the remnants of past eons might be detectable in the cosmic microwave background radiation, the afterglow of the Big Bang. Penrose hypothesizes that circles in the sky, specific patterns in the CMB, could be imprints of black holes from previous universes. These circles, which would look like areas of unusually low energy, might be relics from the previous cycle's black holes. Though this idea is still controversial, some early studies have suggested that there may indeed be faint, unusual features in the CMB that could support this theory. Beyond the scientific implications, conformal cyclic cosmology challenges how we think about time, the universe, and existence itself. If the universe is cyclic, does it mean that life and consciousness are part of an eternal cycle too? Could our actions, lives, and choices have an impact on future cycles? Some philosophers and cosmologists have speculated that the implications of CCC may not just be limited to physics, but could alter our understanding of existence on a deeper level. If the universe is truly infinite in its cycles, what does it mean for the concept of the end of time? Are we part of something eternal? In conclusion, conformal cyclic cosmology offers a radically different perspective on the universe, one that envisions an eternal repeating cycle of cosmic eras. By uniting the ideas of black holes, entropy, and conformal transformations, Penrose has opened up a whole new way of thinking about the cosmos. While many questions remain, CCC is a profound invitation to rethink the origins and fate of the universe in a way that transcends traditional cosmological models. As we continue to explore the universe and develop new tools to study it, theories like CCC could reshape our understanding of reality itself. Perhaps the universe we live in is just one in an endless cycle of cosmic rebirths. Thank you for joining us on this cosmic journey into the concept of conformal cyclic cosmology. If you found this exploration fascinating, don't forget to like, share, and subscribe for more mind-bending topics in the world of science and cosmology.